Hello everyone, welcome to today's session. In the last session, we learned about the supervised learning algorithm. So, in this session, we will learn about the unsupervised learning algorithm. Let's go ahead and understand what exactly is unsupervised learning. So, sometimes the given data is unstructured and unlabeled. So, it becomes difficult to classify the data into different categories. So, unsupervised learning helps to solve this problem. This learning is used to cluster the input data and classes on the basis of their statistical properties. For example, we can cluster different bikes based upon the speed limit, their acceleration, or the average that they are giving. So, unsupervised learning is a type of machine learning algorithm used to draw interfaces from data sets consisting of input data without labeled responses. So, if you have look at the workflow or the process flow of unsupervised learning, the training data is a collection of information without any label. We have the machine learning algorithm, and then we have the clustering models. So, what it does is that it describes the data into a different cluster. And again, if you provide any unlabeled new data, it will make a prediction and find out to which cluster that particular data or the data set belongs to, or the particular data point belongs to. So, one of the most important algorithms in unsupervised learning is clustering. So, let's understand exactly what clustering is. So, clustering basically is the process of dividing the data sets into groups consisting of similar data points. It means grouping of subjects based on the information found in the data describing the object or their relationships. So, clustering model focus on and define groups of similar records and labeling records according to the group to which they belong. Now, this is done without the benefit of prior knowledge about the groups and their characteristics. So, in fact, we may not even know exactly how many groups are there to look for. Now, these models are often referred to as unsupervised learning models since there's no external standard by which to judge model classification performance. There are no right or wrong answers to these models. And if we talk about why clustering is used, the goal of clustering is to determine the intrinsic group in a set of unlabeled data. Sometimes the partitioning is the goal, or the purpose of the clustering algorithm is to make sense of an exact value from the last set of structured and unstructured data. So that is why clustering is used in the industry. And if you have a look at these use cases of clustering in the industry, so first of all, it's being used in marketing. So, discovering distinct group in customer database such as customer who make a lot of long distance calls, customer who use the internet more than calls, they also use insurance companies. So, I need to find groups of corporation insurance policy holder with the high average claim rate, farmers crash crops which are profitable. They are using seismic studies and define problem areas of oil or gas exploration based on seismic data, and they're also used in the recommendation of movies. If you would say, they're also used in Flickr photos. They're also used by Amazon for recommending the product which category it lies in. So basically, if we talk about clustering, there are three types of clustering. So first of all, we have the exclusive clustering, which is the hard clustering. So here an item belongs exclusively to one cluster, not several clusters, and the data point along exclusively. to one cluster. So an example of this is the K-means clustering. So K-means clustering does this exclusive kind of clustering. So secondly, we have overlapping clustering. So it is also known as soft cluster. In this end, item can belong to multiple cluster as its degree of association with each cluster is shown. And for example, we have fuzzy on the C-means clustering, which is being used for overlapping clustering. And finally, we have the hierarchical clustering. So when two clusters have a parent-child relationship or a tree-like structure, then it is known as a hierarchical cluster. So as you can see here from the example, we have a parent-child kind of relationship in the cluster given here. So let's understand what exactly K-means clustering. So K-means clustering is an algorithm whose main goal is to group similar elements or data points into a cluster, and it is the process by which objects are classified into a predefined number of groups so that they are as much dissimilar as possible from one group to another group, but as much as similar or possible within each group. Now, if you have a look at a algorithm working here, so first of all, it starts with an define the number of clusters which is k, then we find the centroid, we find the distance of object to the centroid, then we find the grouping based on the minimum distance has the centroid converse. If true, then we make a cluster false. If you can't find the centroid, repeat all the steps again and again. So let me show you how exactly clustering was with an example here. So first, we need to decide the number of clusters to be made. Now another important task here is how to decide the important number of clusters or how to decide the number of clusters that really get into that letter. So first, let's assume that the number of clusters we have decided is 3. So after that, we provide the centroids for all the clusters which are guessing, and the algorithm calculates the Euclidean distance for the point from each centroid and assigns the data points to the closest cluster. Now the Euclidean distance, all of you know, is the square root of the square of the distance. So next, when the center is calculated, again we have our new cluster for each data point. And again, the distance from the points to the new cluster are calculated, and then again the points are assigned to the closest cluster. And then again we have the new centroid scattered, and now these steps are repeated until we have a repetition. The centroid or the new center eyes are very close to the very precious ones. So until and unless output gets repeated or the outputs are very close enough, we do not stop this process. We keep on calculating the Euclidean distance of all the points to the centroids. Then we calculate the new centroids, and then is how K-means clustering works. Basically, so an important part here is to understand how to decide the values of K or the number of clusters, because it does not make any sense if you do not know how many classes are you going to take. So to decide the number of clusters, we have the ALGO method. So let's assume first of all compute the sum squared error, which is the SSE for some value of A. For example, let's take 2, 4, 6 and 8. Now the SSE, which is the sum squared, is defined as a sum of the square distance between each member of the cluster and its centroid mathematically, and if you mathematically, it is given by the equation which is provided here. And if you bring the key against the SSE, you will see that the error decreases as k gets larger. Now, this is because the number of clusters increases and they should be smaller. So, this torsion is also smaller. Now, the idea of the elbow method is to choose the k at which the SSE decreases abruptly. So, for example, here, if we have a look at the finger given here, we see that the best number of cluster is at the elbow. As you can see here, the graph here changes abruptly after number 4. So for this particular example, we are going to use 4 as a number of cluster. So first of all, while working with K-means clustering, there are two key points to know. First of all, be careful about when you start. So choosing the first center at random, the second center that is far away from the first center. Similarly, choosing the nth center as far away as possible from the closest of all the other centers. And the second idea is to do as many runs of k-means each with different random starting points so that you get an idea of where exactly and how many clusters you need to make and where exactly the centroid lies and how the data is getting conversed. Now, k-means is not exactly a very good method. So, let's understand the pros and cons of k-means clustering. We know that k-means is simple and understandable. Everyone loves you that the first go is the items automatically assigned to the cluster. Now, if we have a look at the cons, so first of all, one needs to define the number of clusters. There's a very heavy task that asks us if we have 3, 4, or if we have 10 categories, and if we do not know what a number of clusters are going to be. It's difficult for everyone, to guess the number of clusters. Now, all items are forced into clusters, whether they are actually belonging to any other cluster or any other category. They are forced to lie in that other category in which they are closest to. This again happens because of the number of clusters with not defining the correct number of cluster or not being able to guess the correct number of clusters. So most of all, it's unable to handle the noisy data and the outliers because anyway, as machine learning engineers and data scientists have to clean the data, but then again it comes down to the analysis, what they are doing, and method that they are using. So typically people do not clean the data for k-means clustering. Even if they clean, there's something and now see noisy and outliers data which affects the whole model. So that was all for k-means clustering. So what we are going to do now is use k-means clustering for a movie dataset. So we have to find out the number of clusters and divide it accordingly. So the use case is that first of all, we have the dataset of 5000 movies. And what you want to do is to group the movies into clusters based on the Facebook likes. So guys, let's have a look at the demo here. So first of all, what we are going to do is import deep copy, numpy, pandas, seaborn, and the various libraries which we are going to use now. And from matplotlib in the use pyplot, and we are going to use this ggplot. And next, what we are going to do is import the data set and look at the shape of the data. So if we have a look at the shape of the data set, we can see that it has 5043 rows with 28 columns. And if you have a look at the head of the data set, we can see it has 5043 data points. So what we are going to do is place the data points in the plot that take a director Facebook likes and we have a look at the data columns, face number, and post cars, total Facebook likes, director Facebook likes. So, what we have done here, now I'm taking the director's Facebook likes and the actor's 3 Facebook likes. So, we have 5043 rows and 2 columns. Now, using the Kmeans from sklearn, what we are going to do is import it. First, we are going to import Kmeans from sklearn.cluster. Remember guys, sklearn is a very important library in Python for machine learning. So with the number of clusters, what we are going to do is provide as 5. Now, this again, the number of clusters depends upon the SSE, which is the sum of squared error, or we are going to use the elbow method. So I'm not going to do into the details of that again. So we are going to fit the data into the kmeans.fit, and if you find the cluster, use them for the kmeans and print. So what we find is an array of 5 clusters, and FA prints the label of the K-means cluster. Now next, what we are going to do is plot the data which we have with the clusters, with the new data clusters which we have found, and for this we are going to use the seaborn, and as you can see here, we have plotted that car. We have plotted the data into the grid, and you can see here we have 5 clusters. So probably what I would say is that cluster 3 and cluster 0 are very close. So it might depends on exactly what I was going to say. Is that initially the main challenge and K-means clustering is to define the number of centers which are K. So as you can see here that the third center and the zeroth cluster, the third cluster and the zeroth cluster up very close to each other. So it probably could have been in one another cluster, and another disadvantage were that we do not exactly know how the points are to be arranged. So it's very difficult to force the data into any other cluster, which makes our analysis a little different. But sometimes it might be difficult to code in the K-means clustering. Now let's understand what exactly C-means clustering is. So the fuzzy C-means is an extension of the K-means clustering, the popular simple clustering technique. So fuzzy clustering, also referred as soft clustering, is a form of clustering in which each data points can belong to more than one cluster. So K-means tried to find the hard cluster where each point belongs to one cluster, whereas the fuzzy C means to discover the soft clusters. In a soft cluster, any point can belong to more than one cluster at a time, with a certain affinity value towards each. Fuzzy C means assign the degree of membership which ranges from 0 to 1 to an object to a given cluster. So there is a stipulation that the sum of the membership of an object to all the clusters, it must be equal to 1. So the degree of membership of this particular point to pull off this cluster is 0.6 and 0.4, and if you add up we get 1. So that is one of the logics behind the fuzzy C means. So, and this affinity is proportional to the distance from the point to the center of the cluster. Now then again, we have the pros and cons of fuzzy C means. So first of all, it allows a data point to be in multiple clusters. That's a pro. It's a more neutral representation of the behavior of genes. Genes usually are involved in multiple functions. So it is a very good type of clustering when we are talking about genes. First of all, if we talk about the cons again, we have to define C, which is the number of cluster the same as k. Next, we need to determine the membership cutoff value also. So that takes a lot of time and it's time consuming. And the cluster are sensitive to initial assignment of centroid. So a slight change or deviation from the center has it's going to result in a very difficult kind of, you know, a funny kind of output we get from the fuzzy C-means. And one of the major disadvantage of C-means clustering is that it's this non-deterministic algorithm. So it does not give you a particular output as in such that's that. Now let's have a look at the third type of clustering, which is hierarchical clustering. So hierarchical clustering is an alternative approach which builds a hierarchy from the bottom up or the top to bottom and does not require to specify the number of clusters beforehand. Now the algorithm works as in first of all we put each data point in its own cluster, and if I am the closest to cluster and combine them into one more cluster, repeat the above step till the last data points are in a single cluster. Now there are two types of hierarchical clustering. One is agglomerative clustering and the other one is division clustering. So agglomerative clustering builds the dendrogram from bottom level, which the division clustering start all the data points in one cluster, the fruit cluster. Now again, hierarchical clustering also have some sort of pros and cons. So the pros don't know assumption of a particular number of cluster is required and it may correspond to a meaningful taxonomist. Whereas if we talk about the cons, once a decision is made to combine two clusters, it cannot be undone. And one of the major disadvantage of this hierarchical clustering is that it become very slow if we talk about very large data sets. Nowadays, I think every industry is using last year as its and collecting large amount of data. So, hierarchical clustering is not the act or the best method someone might need to go for. So, this that now then we talk about unsupervised learning. We have Kmeans clustering, and again another important term which people usually miss while talking about unsupervised learning. And there's one very important concept of market basket analysis. Now, it is one of the key techniques used by large retailers to uncover association between items. Now, it works by looking for a combination of items that occur together frequently in the transaction. To put it in another way, it allows retailers to identify the relationship between the items that the people buy. For example, people who buy bread also tend to buy butter. The marketing team at the retail stores should target customers who buy bread and butter and provide them an offer so that they buy a third item like an egg. So, if a customer buys bread and butter and seeks a discount or an offer an eggs, he will be encouraged to spend more money and buy the eggs. Now, this is what market basket analysis is all about. Now, to find the association between the two items and make predictions about what the customers will buy, there are two algorithms which are the association rules mining and the a priori algorithms. So, let's discuss each of these algorithm with an example. First of all, if we have a look at the association rule mining now, it's a technique that shows how items are associated to each other. For example, customer who purchased Sprite have a 60% likelihood of also purchasing jam, and customer who purchases laptops are more likely to purchase laptop bags. If you have take an example of an association rule. If we have a look at the example here, A arrow B, it means that if a person buys an item A, then he will also buy an item B. Now, there are three common ways to measure a particular association because we have to find these rules not on the basis of some statistics. So, what we do is use support, confident, and lift. Now, these three common ways and the measures to have a look at the association rule mining and know exactly how good is that rule. So first of all, we have support. So support gives the fraction of the which contain an item A and B. So it's basically the frequency of the item in the whole item set, where confidence gives how often the item A and B occurred together given the number of items and times A occurs. So its frequency A comma B divided by the frequency of A. Now left, what indicates the strength of the rule over the random co-occurrence of A and B. If you have a close look at the denominator of the lift formula here, we have supported A into support B, and now a major thing which can be noted from this is that the support of A and B are independent here. So if the value of lift or the denominator value of the lift is more, it means that the items are independently selling more, not together. So that is turn will decreases the value of lift. So what happens is that suppose the value of lift is more, that implies that the rule which we get, it implies that the rule is strong and it can be used for later purpose, because in that case the support into support B value, which is the denominator of lift, will be low, which is turn means that there is a relationship between the item in the B. So let's take an example of association rule mining and understand how exactly it works. So let's suppose we have a set of items A, B, C, D and E, and we have the set of transaction which are T1, T2, T3, T4 and T5. And what we need to do is create some sort of rules. For example, you can see AD, which means that if a person buys A, he buys D. If a person buys C, he buys A. If a person buys A, he buys C. And for the fourth one is if a person buys B and C, it turns they buy A. Now what we need to do is calculate the support, confidence and lift of these rules. Now here again we talk about a priority algorithm. So a priority algorithm and a association rule mining go hand in hand. So what is the Apriori algorithm? It uses the frequent item set to generate the association rules, and it is based on the concept that a subset of a frequent item set must also be a frequent item set. So let's understand what is a frequent item set and how all of this work together. So if we take the following transaction of items, we have transaction T1 to T5 and the items are 134, 235, 1235, 25 and 135. Now another more important thing about support which I forgot to mention was that when talking about association rule mining, there is a minimum support count what we need to do. Now the first step is to build a list of items of size 1 using this transaction dataset and use the minimum support count too. Now let's see how we do that. If we create table C, when you have a close look at table C1, we have the items at 1 which has support 3 because it appears in the transaction 1, 3 and 5. Similarly, if you have a look at the item set, the single item 3, so it has the support of 4. It appears in T1, T2 and T3 and T5. But if we have a look at the item set 4, it only appears in the transaction once, so its support value is 1. Now the item set with the support value which is less than the minimum support value, that is 2, have to be eliminated. So the final table, which is a table F1, has 1, 2, 3 and 5. It does not contain the 4. Now what we are going to do is create the item list of size 2 and all the combination of the item sets in F1. I used it in the iteration. So we are left 4 behind. We just have 1, 2, 3 and 5. So the possible item sets are 1, 2, 1, 3, 1, 5, 2, 3, 2, 5 and 3, 5. Then again, we will calculate the support. So in this case, if we have a closer look at table C2, we see the item set 1, 2 is having a support value 1, which has to be eliminated. So the final table F2 does not contain 1, 2. Similarly, if we created the item sets of size 3 and calculated these support values, but before calculating the support, let's perform the pruning on the data set. Now, what's pruning? So, after all the combination are made, we divide the table C3 items to check if there is another subset whose support is less than the minimum support value. This is Apriori algorithm. So, in the item sets 1, 2, 3, we can see that we have 1, 2, and in the 1 to 5 again, we have 1, 2. So build this cardboard of these item sets and we will be left with 1, 3, 5 and 2, 3, 5. So with 1, 3, 5, we have 3 subsets 1, 5, 1, 3, 3, 5, which are present in table F2. Then again, we have 2, 3, 2, 5 and 3, 5, which are also present in table of 2. So if we have to remove 1, 2 from the table C3 and create the table F3, now if you are using the items of C3 to create the items of C4, so what we find is that we have the item set 1, 2, 3, 5, the support value is 1, which is less than the minimum support value of 2. So that we are going to do is stop here and we are going to return to the previous item set, that is table C3. So the final table F3, well, if 3 was 135 with the support value of 2 and 235 with the support value of 2, now what we are going to do is generate all the subsets of each frequent item set. So let's assume that minimum confidence value is 60%. So for every subset S of I, the output rule that S gives I to S is that S recommends INS. If the support of I is divided by support of S is greater than or equal to the minimum confidence value, then only will proceed further. So keep in mind that we have not used left till now. We are only working with support and confidence. So applying rules with item sets of F3, we get rule 1, which is 1, 3, which gives 135 and 1, 3. It means if you buy 1 and 3, there is a 66% chance that you will buy item 5 also. Similarly, the rule 1, 5, it means that if you buy 1 and 5, there's 100% chance that you will buy 3 also. Similarly, if we have a look at rule 5 and 6 here, the confidence value is less than 60%, which was the assumed confidence value. So, what we are going to do is to reject these files. Now, an important thing to note here is that have a closer look at the rule 5 and rule 3. You see, it has 153, 153, 315. It's very confusing. So, one thing to keep in mind is that the order of the item set is also very important and will help us create good rules and avoid any kind of confusion. So, now let's learn how association rules are used in market basket analysis problem. So, what we'll do is we will be using the online transaction data of a retail store for generating association rules. So, first of all, what you need to do is import pandas mixed libraries from the imported and read the data. So, first of all, what we are going to do is read the data. What we are going to do is from MLX 10 dot frequent patterns, we are going to improve the a priori and association rules. As you can see here, we have the head of the data. You can see we have invoice number, stock code, the description quantity, the invoice details, unit price, customer ID, and the country. So, in the next step, what we will do is we will do the data cleanup, which includes removing spaces from some of the descriptions given, and what we are going to do is drop the rules that do not have the invoice number and remove the credit transaction. So what you are going to do is remove the invoice which does not have any invoice number. If the string contains type C number, then we are going to remove that. Those are the credits that remove any kind of spaces from the descriptions. So as you can see here, we have like 532,000 rows with 8 columns. So next one we are going to do is after the cleanup, we need to consolidate the item into one transaction per row with each product for the sake of keeping the dataset small. We are going to only look at the sales for France. So we are going to use only France and group by invoice number description with the quantity sum up and CISO, which leaves us with 392 rows and 1563 columns. Now there are a lot of zeros in the data, but we also need to make sure any positive values are converted to a 1 and anything less than 0 is set to 0. So for that, we are going to use this code defining and code units. If x is less than 0, return 0. If x is greater than 1, return 1. So what we are going to do is map and apply it to the whole data set we have here. So now that we have structured data properly. So the next step is to generate the frequent item set that has support of at least 7%. Now this number is chosen so that you can get close enough. Now what we are going to do is generate the rules with the corresponding support, confidence and lift. So we had given the minimum support as 0.7. The metric is left, frequent item set and threshold is 1. So these are the following rules. Now a few rules with a high lift value, which means that it occurs more frequently than would be expected given the number of transactions, the product combinations, most of the places the confidence is high as well. So these are a few observations that we get here. If we filter the data frame using the standard pandas, code for large lift 6 and high confidence 0.8. This is what the output is going to look like. These are 1, 2, 3, 4, 5, 6, 7, 8. So as you can see here, we have the 8 rules, which are the final rules, which are given by the association rule mining, and this is how all the industries are. Are any of these? We have talked about largely retailers. They tend to know how their products are used and how exactly they should rearrange and provide the offer on the product so that people spend more and more money and time in their shop. So that was all about association rule mining. So, guys, that's all for unsupervised learning. I hope you got to know about the different formulas of how unsupervised learning works because we did not provide any label to the data. All we did was create some rules and not knowing what is the data, and we did clustering, different type of clustering, K-means, C-means, hierarchical clustering. So, this is all about today's session. If you have any more questions, feel free to ask me in the comment box below. Thanks for watching and have a great day.